Hi, hello dear students. Welcome to our channel Maths with PHANEENDRA. In this video, two-dimensional geometry basics, prerequisites of 2D geometry. We already discussed two videos in our playlist. This is the third video regarding concurrent lines and point of concurrency. So what is meant by concurrent lines? What is point of concurrency? That we are going to discuss in this video. And what are the point of concurrencies respective terms and the definitions we are going to discuss. So concurrent lines and point of concurrency. When three or more lines in a plane which intersect one another exactly at one and only one point, exactly at one point or one and only one point, are called concurrent lines, and the common point is called concurrent point or point of concurrency. See here, these are the lines, three or more lines which are intersecting one another, intersecting at one point. Here one point is what? P, which are intersecting at the point P. Then these lines are called concurrent lines, and the common point P for all the lines which are intersecting at this point, the concurrent point is called concurrent point or point of concurrency. So the lines which are intersecting at one and only one point is there. Now this point is called point of concurrency or concurrent point. So what are the concurrent points? These concurrent points can be divided into point of concurrencies, point of concurrency divides in that first type of point of concurrency, centroid. It is denoted by G. What is meant by centroid? The point of intersection of the medians of the triangle is called centroid. Next, orthocenter. It is denoted by capital O or capital H. Orthocenter. What is meant by orthocenter? The point of intersection of altitudes of the triangle is called orthocenter. Next, circumcenter. Circumcenter denoted by S. Circumcenter is denoted by S. What is the definition of circumcenter? The point of concurrency of or point of intersection of perpendicular bisectors of the triangle is called circumcenter. Perpendicular bisectors of the triangle is called circumcenter. Next, incenter. It is denoted by capital I. What is meant by incenter? The point of intersection of internal angular bisectors is called incenter. Point of concurrency or point of intersection of internal angular bisectors is called incenter, which is denoted by I. After that, one more result is there, that is excenter. It is denoted by I1, I2, I3. So three are there. Clearly each and every term and their properties, their reasons we are going to discuss in this video. Each and every centroid first I will consider. What is the definition of centroid? What are the properties? What is the formula to find centroid? I will explain in each and every term of this point of concurrencies. See, excenter. What is the definition of excenter? The point of intersection of one internal bisector and two external bisectors is called X-center. To the opposite vertex, X-center. So I will explain clearly each and every term with figures. So point of concurrencies which are dividing in these way. So one by one clearly we will explain. First we will discuss about the centroid of the triangle and the respective properties. We will move on to that. Yeah, before that we need to discuss if the lines are concurrent, find the unknown value. Suppose the lines are like this. The lines a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0, and a3x plus b3y plus c3 equal to 0. If the lines are concurrent, then find unknown value or point of concurrency of these lines. Point of concurrency of these lines. How it is? So, two methods are there. First method is, you put that equation number 1, 2 and 3. Solve any two equations among the three, will get point of intersection x comma y. That x comma y substitute in the rest of the equation. Suppose if you are considering first equation, second equation, if you solve it, you will get x comma y values. That x comma y values substitute in equation 3. If it satisfies, then the lines are concurrent. Otherwise, not concurrent. So alternate method I am saying. This is first method. So first method is solve any two equations among the three. We'll get x comma y point of concurrency. That you can substitute in the rest of the equation. If it satisfies, the lines are concurrent. Otherwise, not concurrent. Now, the shortcut generally, the lines are concurrent. Lines are concurrent if and only if the determinant formed by these lines with x coefficient, y coefficient and constant in the three equations a1, b1, c1, a2, b2, c2, a3, b3, c3 is equal to 0. If the lines are concurrent, the determinant of formed by the lines with x coefficient, y coefficient and constant terms in the respective equations. If this determinant equal to 0, then the lines are concurrent. Based on this, they will ask the questions. We have a number of questions. We applied this concept in number of possibilities. And moreover, the point of concurrency means concurrent lines. How to represent a family of concurrent lines, that also will come. Just a little concept. So L1 among these lines, one line I am taking as L1 equal to 0, L2 equal to 0, L3 equal to 0, like this and so on. How many lines are there? You can write. The family of straight lines can be represented as the family of concurrent lines. The family of concurrent lines represents in the form lambda 1 into L1 plus lambda 2 into L2 equal to 0. So this also we can write as L1 plus lambda 2 by lambda 1. That means lambda 1 I am taking common. L2 equal to 0. This lambda 2 by lambda 1 I am taking as, here anyway lambda 1, lambda 2 which are constants that belongs to R. Even here lambda 2 by lambda 1 is equal to some constant lambda which belongs to R. I am assuming that. So this equation will becomes L1 plus lambda L2 equal to 0. Now onwards, it represents the family of lines, the concurrent lines is in the form of L1 plus lambda L2 equal to 0. in place of 1 comma 2, I comma j, if you put that Li plus lambda Lj equal to 0, where I is equal to 1, 2, 3 and so on. Here also j is equal to 1, 2, 3 like this, different lines. We'll take it. So this represents the family of concurrent lines. The family of concurrent lines, always representing in this form, either lambda 1 into L1 plus lambda 2 L2 equal to 0, or L1 plus lambda L2 equal to 0 is called family of concurrent lines, or representing concurrent lines. This is about concurrent lines and condition. This is the condition for the concurrent lines. Shortcut formula based on the determinant of 3 by 3 matrix. So this one is a condition, concurrent lines, family of concurrent lines generally. L1 we are representing in this way, L1 plus lambda L2 equal to 0. Now we will discuss about the centroid and the information about centroid. Yeah, next the concept of centroid we will discuss now. What is the meaning of centroid? The point of intersection of medians in a triangle is called centroid. It's called centroid. What is called median? The line joining of the midpoint of the opposite side to the vertex and the vertex. Here A is one of the vertex. Opposite side is BC. The midpoint of BC is D here. Line joining of midpoint of the opposite side to the vertex and D is called median of the triangle. So like this, three medians we have. The point of intersection of these three medians is called centroid. It is denoted by capital G. You remember, it's very important concept of centroid. It is denoted by capital G. Related to medians and centroid, one important property, most of the questions having this concept, based on this concept we will apply the result. The centroid G divides the median in the ratio 2:1 internally. See here, centroid G, it divides the median AD or BE or CF. It divides in the ratio of 2:1 internally. You remember, dear students, this is very important property. Centroid divides the median in the ratio of 2:1 internally, especially internally you put it in. Now let A of x1 y1, B of x2 y2 and C of x3 y3 are the vertices of a triangle ABC, then centroid G of x comma y is defined as x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. We will discuss the proof also, but proof D is the midpoint now. So x2 plus x3 by 3 here, 2, y2 plus y3 by 2 here. After that, A and D points are there. The centroid G divides the line joining of A of x1 y1, B of D of x2 plus x3 by 2, comma y2 plus y3 by 2 in the ratio of 2:1. Internal division formula, if you apply, you will get this formula: x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. x1 plus x2 plus x3 means what? Sum of the abscissa. Abscissa means x coordinates. Sum of x coordinates by 3. y1 plus y2 plus y3. Sum of the y coordinates or ordinates. Sum of the y coordinates by 3. Here total 3 are there, no? 3 are there. So sigma I is equal to 1 to 3 xi by 3. Sum of the x coordinates by 3 and sum of the y coordinates by 3. I is equal to 1 if you substitute. So I is equal to 1 means x1, I is equal to 2, x2. Sigma represents sum of. So sigma I is equal to 1 to 3 xi by 3, sigma I is equal to 1 to 3 yi by 3. This is about centroid and the formula. Based on centroid, we have some results. Most important results I am explaining here. The first proposed result: if G is the centroid of triangle ABC, area of triangle ABC is 3 times the area of triangle ABC. See here, observe this figure. Area of triangle ABC is equal to area of triangle 3 times the area of triangle GAC, area of triangle GBC 3 times of area of triangle AGB. That's what I wrote here. How to remember easily? Area of triangle ABC is equal to 3 times of area of ABG. So C is not there here. In the next term, BC will be there, A is not there, G will be there. Next, area of triangle CA, B is not there, G. So like this, area of triangle ABC is equal to 3 times of area of triangle ABC, 3 times of area of triangle BCG, 3 times of the area of triangle ACG. This is the way, this type of question, how they will ask the question based on this concept. They will give centroid. Among the 3 vertices, any 2 vertices they will give. Ask them to find the area of triangle ABC. After this video or another video, more 2 videos I want to do this based on this. After that I will give that examples based on these concepts, whatever concepts I am explaining in this video. Based on that questions I am explaining, that means MCQs. So 3 times of area of triangle CAG like this. Now come to another one. AB square plus BC square plus CA square. What is the meaning? AB square, that means sum of the squares of the sides of the triangle. AB square plus BC square plus CA square is equal to 3 times of GA square plus GB square plus GC square. So sum of the squares of these 3 sides is equal to 3 times of GA square plus GB square plus GC square. Not only this one, which is also equal to 4 by 3 times of AD, BE, CF, which are called medians of the triangle. So 4 by 3 times of sum of the squares of their medians, AD square plus BE square plus CF square. So sum of the squares of the triangle ABC, that means AB square plus BC square plus CA square equal to 3 times of GA square plus GB square plus GC square, and also equal to 4 by 3 times of 4/3 of P. 4/3, that means 4 by 3 times of AD square plus BE square plus CF square. This is related to medians and sides including centroid. Now we will move on to the third property. Third important result. P is any point in the triangle ABC. It is showing like this. Where G is the centroid of the triangle, then PA square plus PB square plus PC square. Distance, the sum of the squares of the distances PA, PB, PC. PA square plus PB square plus PC square is equal to GA square, that means from here to here, plus from here to here, GA square plus GB square plus GC square plus 3 times of GP square, 3 times of GP or PG. So once again I will repeat the distance, the sum of the squares of distances of PA, PB, PC. PA square plus PB square plus PC square equal to GA square plus GB square plus GC square plus 3 times of PG square or GP square. This is also one of the best result. How they will ask the question based on this. Even here also, in the second property also, how they will ask the question. Centroid, otherwise median lengths they will give AD value, BE value and CF value. They will ask to calculate sum of the squares of sides of the triangle. Otherwise, GA square plus GB square, they will give AB, BC, CA lengths. AB, BC, CA lengths they will give. They will ask to calculate GA square plus GB square plus GC square. So if you remember this property, this result, it will be easy to find the answers in the competitive examination. Dear students, we will move on to the third also completed. In this third result, how they will ask the question? They will give that PA square plus PB square plus PC square. Otherwise, they will ask the question linked with the second property and third property also. Why? Because here GA, GB, GC is unknown. These values will calculate from here now. They will give A, B, B, C, C, A, and P point also they will give. And they will ask to calculate G A square plus GB square, A B square plus BC square plus C A square. So, along with that concepts they will ask. So, they will mingle with the property 2 and property 3, they will ask the questions. Now, we will move on to the fourth property, important. If D, E, F are midpoints of the sides of the triangle BC, AC and AB, so D is the midpoint of BC, E is the midpoint of AC and F is the midpoint of AB. So midpoints is given here. So whenever the midpoints of the sides of the triangle is given, the centroid of triangle ABC is equal to the centroid of triangle DEF. This is very important property, dear students. Remember, they will give that midpoints of the sides of the triangle. Generally, how they will ask the question? They will give midpoints of the sides of the triangle. They will give D point. They will give E point and F point. They will give. They will ask to calculate the centroid of triangle ABC. So, if we calculate centroid of DEF, it is equal to centroid of triangle ABC. So, based on this, they will ask. So, this is about regarding centroid. Most of the important results I explained here. We will move on to the next orthocenter. Orthocenter. Yeah, we will enter into the another concept, orthocenter. What is meant by orthocenter? The point of intersection of altitudes in the triangle ABC is called orthocenter. It is denoted by O or H. Either O or H. So this is the triangle ABC. AD is an altitude through the point A, BE is an altitude through the point B, and CF is an altitude through the point C. These are the altitudes. The point of intersection of altitudes is called orthocenter. It is denoted by O. After that, orthocenter especially is a particular case of right angled triangle. For other triangles, a different way we will do that, general method only. For the right angled triangle, especially in a right angled triangle, the orthocenter is right angle at vertex. See, for example, here three triangles I drawn, the right angled triangles A, B, C. Right angle at vertex A here, no? So, if the right angle at A, therefore A is called orthocenter in this case. Orthocenter. Suppose the triangle will be like this, BAC. It is also right angle triangle, but right angle at what point? B point. So, orthocenter for this triangle is B. CAB. So, right angle triangle at C. So, C is orthocenter for the triangle ABC. If you decide that, if you recognize the given points forms a right angle triangle at some vertex, that point is called orthocenter for the given triangle. Now, come to another new concept, new point. Orthic triangle or pedal triangle. What is meant by pedal triangle or orthic triangle? The triangle formed by the feet of altitudes in a triangle called orthic triangle or pedal triangle. See, pedal triangle means, observe the figure. The triangle formed by the feet of altitudes. AD is one altitude, BE is another altitude, and CF is third altitude in the triangle. The feet of altitude is D here. And for BE is the feet of altitude and CF altitude, F is the feet of altitude. So the triangle formed by feet of altitudes, so DEF, if you join these 3 points, you will get one triangle DEF. The triangle DEF is called pedal triangle or orthic triangle. Observe carefully, dear students, this concept is important. In the JM it's advanced they will ask, but you have to know about this concept. That is my intention, to give that minimum knowledge about these concepts. That is the reason I am doing this video. In my free time I am doing this one. I hope you understand that. It will be helpful for most of the students. They make comments in my channel. I appreciate, and you can utilize, you can share, you can support to my channel. Yeah, come to what was pedal triangle? The triangle formed by the feet of altitudes of the triangle is called pedal triangle. From the figure, triangle DEF, from triangle DEF is called pedal triangle. Is called pedal triangle or orthic triangle. Make a note, dear students. This is called pedal. From the figure, triangle DEF is called pedal triangle. Now, shortcut formula. When the vertices are given like this, that means one of the vertex is origin. The orthocenter of triangle formed by with the vertices 0, 0, x1, y1, x2, y2 is 0, 0, x1, y1 and x2, y2 is. So, x coordinate, when the points are in this form, x1, x2 plus y1, y2, product of x coordinates plus product of y coordinates by x1, y2 minus x2, y1 into y2 minus y1. These two bracket values are same. Observe carefully, dear students. x1, x2 plus y1, y2 by x1, y2 minus x2, y1 into x1 minus x2. For x coordinates, difference of y coordinates we are multiplying y2 minus y1. Here, for this bracket value multiplying by y coordinate means multiplying by the difference of x coordinate x1 minus x2. So these two are, this is the shortcut formula to get orthocenter of the triangle when the points are in that form. O of x comma y. O means here orthocenter, not origin. I already said that either O or H you can denote. So what is the general procedure to calculate the orthocenter of the given triangle? See, general procedure I am explaining. A, B, C. So 3 points they will give. Find orthocenter of the triangle. Orthocenter definition is what? The point of intersection of altitudes only, no? So among the 3 altitudes, any 2 required, no? To get the point of intersection. Any 2 is enough. So I am considering here AD is one altitude and BE is another altitude. So A point, B point and C point they will give. Altitude means which are always perpendicular only, na? So AD slope I want. BC is perpendicular, AD is perpendicular to BC. So slope of AD is perpendicular to BC. That implies that slope of AD is equal to minus 1 by slope of BC. So slope of BC how to calculate? When 2 points are available, y2 minus y1 by x2 minus x1, by using that formula, get the slope of AD. This is slope of AD is m, and passing through which point? A point. So AD equation of altitude AD. Equation of altitude AD. So by using the formula y minus y1 equal to m into x minus x1, you put that equation number 1. Next, AC altitude calculate. AC, BE is perpendicular to AC. So BE is perpendicular to AC. That implies slope of BE is equal to minus 1 by slope of B only. Slope of B is equal to slope of AC. Slope of AC how to calculate? 2 points are there, y2 minus y1 by x2 minus x1. You can do that. So this is also you can assume that m. This equation is passing through B point only, no, E is not there. So B point. So equation of altitude BE. So again by applying the formula y minus y1 equal to m into x minus x1. In this case x1, y1 points are A. In this equation the point is B here, dear students. You remember? Put that equation number 2. Solving 1 and 2. We get orthocenter O of x comma y. This is the general procedure, students. When one of the vertex is origin and other points are x1, y1, x2, y2, so this is the shortcut formula to calculate the orthocenter. If it is not in this form, so general procedure I explained here. We'll move on to the next concepts in the next video. Thank you. Signing off, Maths with Phaneendra. In the next video means we will get Centroid completed. After that, Orthocenter, Circumcenter and In-center, X-center. In the three, I will keep another video, otherwise I will make it all and one video. Okay, thank you all. Signing off, Maths with Phaneendra.